Hello, Isaac Ajao. I want to show us how to perform simple linear regression in Excel. Simple linear regression in Excel. So, assuming I want to use this dataset, I assume this is my y, this is my x. Mostly, we prefer using y as our dependent variable, while x is chosen as a predictor or independent variable. So many names for this attribute I just mentioned. The dependent variable can be called the response variable. Actually, it is responding to whatever this variable is saying. We may have more than just one x. You can have others. You can have x1, x2, x3. But in this case, we want to deal with simple linear regression. Now, just go to already we come to pick data here. Then once you click on data at the menu, if analysis to pack is installed on your Excel, you have this data analysis here. So you click this. Don't forget the aim of this analysis to carry out regression analysis to establish relationship, to test whether there's relationship between these two variables. We know our response variable, we know our independent variable. So we are here. Look for regression. This is regression. Click on it. So inputs y range. Y range is here. You must know your response variable anyway. I may not call this y range, but the default is y. So you click it on your x for y range. This has your independent variable. Then labels. Check on labels. Constant is 0. Then we assume that the constant is 0 that is default. The output range where we want your results. I prefer my result to be beside my data. Then residual. You may need residual plots. It depends on the one you need. Prefer these two. Number probability plots. These are you want to know, you are testing for normality. There are some shapes that this one will give us that we know that the data is normally distributed or not. Then click OK. The result is here. You can see multiple R. This R square or just R square talk about the goodness of it. That is, we call it coefficient of determination. This talk about how good your model is. That's why we call it goodness of fit measure. This is standard error. These are now observation. We have 7 observations here. This is an ANOVA table. Analysis of variance table. This is regression, residual. This EDF is a degree of freedom. This is sum of square. This is mean square. This is F. Then this one is significance. It's what we call p-value. Except we not write p-value, it's call it significance F. You can see now. Let me quickly explain this. So this is the model. If you want to write the model out here, it's just very simple. You just write y equals, this is the intercept, and this is the intercept. This is your alpha plus beta x. This is our x. So these are beta. The one I want to write is now, as we want to write this model out. Let me write it for us. I want to use notepad, pick. You can just say y, the model, or let's say regression model is equal to, see, I want to copy from this. Is it plus is the beta, that's parameter estimate, or the slope, call it slope in physics, So removing this is too long. Can have just very significant figures of the decimal place and put our x here. Our x can be here. So regression model, see y is equal to this. You can see the way I bring out my model from this. So this is beta, this is our y, this is our x. So it's not more than this. Then residual output is here. You can see from this model you want to predict what your y will be using the model. Meaning that if you put the value of your x wherever you have x in the equation, these are the predicted value. Otherwise, we can see that these are the values that we predicted using the model. See this model here. For instance, if you put the value here at where you have your y, if you put 1 here now, this is what you're going to have. That's what it means. If you put value here again, you're going to have this one. For each of those x, is what you're going to be having here. It's no more than this. Thank you.